Yeah, so we are continuing with our questions. So I want to just clarify this example from the notes. Maybe do it. Yeah, do it. I'll do it. Uh, and also, the way I'm doing it here might be different from the approach that you already know. And if the approach that you already know seems simpler and understand it, please stick to it. So we have a question here. When 50 ml of HCl is titrated with 0.7450 molarity, the pH increases. Then the first question is that what volume of sodium hydroxide is required to reach the equivalence point and a pH of 7? So yeah, I think let me attempt to answer question A. Yes. So what volume of sodium hydroxide is required to reach the equivalence point? Right. So I think before we go any further, you see that if you look at the question, when 50 ml of HCl, right, of one mole, the molarity of HCl is titrated. So I think the first thing you need to find here is to calculate the moles of, step number one, calculate the moles of HCl. And how do you do that? The moles of HCl, I think we can simply agree that it's just the volume of HCl multiplied by the molarity of HCl, or multiplied by the molarity of HCl. Yeah. So this means that the volume of HCl, we're given it's simply 50.0 milliliters, and we need to convert this to liters. So we just multiply by 1 liter over 1000 ml, so that ml cancels ml, and you're given the molarity. It's from the question, it's 1.0, and this will yield, press my calculator, this will give me 0.0500 mole of HCl. So if I have the moles of HCl, that means I can go ahead and calculate the volume of sodium hydroxide. Now, how do I do that? Now, to calculate the volume of sodium hydroxide required to reach the equivalence point, we need to agree that the moles of HCl equals to the moles of sodium hydroxide. Like that means the moles of HCl is equals to the mole of sodium hydroxide. So I can conclude that the mole of sodium hydroxide is simply this. So 0.0500 mole of sodium hydroxide. So now that means I can easily calculate the volume of sodium hydroxide. So to calculate the volume of sodium hydroxide, I may simply say the moles then I can divide for the volume I can divide by the concentration, which is 0.7450. This will give me 0.06711 in liters, and then maybe I can convert it to milliliters, since everything we're given from the question is in milliliters. So this 6.711 ml. So this will be the answer for part A. So I think this was basically simple. If you look at it, what volume of sodium hydroxide it requires to reach the equivalence point, and a pH of 7. So I think for the pH of 7, I think it's just I didn't really see the need to tell us about the pH, because since I can calculate the moles of sodium hydroxide required to reach the equivalence point without even using the pH. So that's basically it. So this is very, very simple. So now, moving on to part B. What does part B says? Part B says find the pH when the volume of sodium hydroxide is added is 0.02 ml, less than the volume required to reach the equivalence point. That means from the start we just need to subtract. We just need to subtract this 0.02 ml from this 67.11 here. So that's the first approach before we go any further. So that means I can start to subtract 67.11 ml minus 0.02 ml. And then if you press your calculator, this will give you 67.09 ml. So this is the volume. So this is the volume of sodium hydroxide added when it is 0.02 ml less from the equivalence point. So now we need to find the moles of sodium hydroxide added. So we need to find the moles of sodium hydroxide added. Now, how can you find this? You can simply find this by multiplying the volume of sodium hydroxide multiplied by the molarity of the sodium hydroxide, because we were given the molarity of sodium hydroxide. So that means 67.09 ml. Now I need to simply convert it to liters. That's 1 liter over 1000 ml, then multiplied by the molarity, which is 0.7450. Yes, so then this will give me 0.4998 moles. So we are going to need this. So I'm just trying to find the moles of sodium hydroxide added, right? So now we need to find the moles of HCl remaining after the reaction with sodium hydroxide. Now, how can we find that? You can find the moles of HCl remaining after the reaction with sodium hydroxide by simply subtracting the initial, initial minus moles of sodium hydroxide added, right? So what was the initial moles? The initial moles, we can both agree that it's 0.05, then multiplied by the moles that we just calculating, subtracting by the moles of, that's 0.4998 moles. So if you press your calculator very well, this will give you 0.0000 moles. So yeah, no, there are 4 zeros. They are 4 zeros. 2 moles. So now after calculating the moles of HCl that are remaining after reacting with sodium hydroxide, that means we can calculate the total volume of the solution. So how can we find the total volume of the solution? Please, I hope everyone is following. So how can we find the total volume of the solution? Now, the total volume of the solution, you can simply add the volume of HCl and the volume of sodium hydroxide. And the volume of the solution, I think it's, let me change the marker. The volume of the solution, that's 50.0 ml. And I'm going to add 67.09 ml. This will give you something like 117.09 ml. Then maybe convert it to liters. It will simply be 0.11709 liters. So you're still going to need this. So yeah, that's basically it. So now we are moving on. Now, why was I calculating the moles of HCl remaining and the total volume of the solution? I was calculating this so that I can find the concentration of HCl remaining in the solution. Now, since I have the moles of HCl remaining and the total volume, I can find the concentration. All of this, we're doing this so that we can find the concentration of HCl that is remaining. So how can we find that? I can simply do that by dividing the moles of HCl remaining by the total volume. And remember, the moles of HCl that was remaining, it was 0.002, and the total volume we just calculated it here, 0.11709. And then if you press your calculator, this will simply be 0.001708. So that's the concentration of the HCl that is remaining. So now, after finding the total concentration of the HCl that is remaining, so what can we do? We can use this to find our pH, right? We can use HCl to find our pH. Now I'm going to do it. Now remember that pH is equals to negative log concentration of H plus, right? And then this equals to negative log HCl. Yes, so that means I can put this concentration in my formula. That means therefore my pH simply equals negative log concentration. It was 0.001708. Then if you press my calculator very well, that will give us 3.767. So basically that's it. So that's the answer. So I hope everyone was following. So the best thing you can do for yourself is to find a strategy that works for you, or a pathway that works for you in every question. So in this question, this is my desired way because it's just simple. I feel it's simple to me. So, and also make sure that when you watch this video, please, you know I was not writing down the steps. So you write down the steps so that you understand later, then you reflect. But this is the way I advise you to do this question. If you don't have any other way, that is, maybe you'll remember. And this works in most of the questions. So goodbye.